Now, what are the objectives? You should be able to determine whether two matrices are equal, and you should be able to add and subtract matrices and multiply a matrix by a scalar. Also, for you to multiply two matrices and use matrices to solve a system of linear equation. You should also be able to partition a matrix and write a linear combination of column vectors. Now, what makes matrices equal? According to this definition, two matrices A and B with respective entries A sub ij and B sub ij are equal when they have the same size, that is an m by n size, and for which A sub ij is equivalent to B sub ij for I from 1 to m and for j from 1 to n. Now, let us apply the concept of equality of matrices. Consider the four matrices A, B, C, and D, wherein A is a 2 by 2 size matrix, B is a 2 by 1 matrix, C is a 1 by 2 matrix, and D is a 2 by 2 matrix. Matrices A and B are not equal because they don't have the same size. Also, B and C are not equal because they are not of the same size. But since A and D are of the same size, then we can apply the equality of matrices. Notice that A and B can only be equal if X is 2. Now, a matrix that has only one column is called a column matrix or a column vector. Similarly, a matrix that has only one row is a row matrix or row vector. Now, knowing the size of the matrix, we can now try to operate on the matrices using matrix addition, subtraction, and scalar multiplication. For matrix addition, subtraction, and scalar multiplication, we can add two matrices if they are of the same size, and such that we will only be adding their corresponding entries. Definition of matrix addition. If A is a matrix, that's an m by n matrix, whose entries are A sub ij, and B is also an m by n matrix with entries B sub ij, then the sum A plus B will have entries to be, so we will have A sub ij plus B sub ij for I, again, that is from 1 to m, and j from 1 to n. So the sum of two matrices of different sizes is undefined. Example, let us add the following matrices. You have a 2 by 2 matrix. We have A, wherein we will have a two pairs of 2 by 2 matrices. So in order to find the sum, we only add the entries with the same position. So for example, -1 plus 1, that would be 0. 2 plus 3, that would be 5. And then you have 0 plus -1 is -1. And then you have 1 plus 2 equivalent to 3. Similarly for B, wherein we will have a pair of a 2 by 3 matrices. So we simply add element-wise. Now for C, we're adding two column vectors. So, and we see here that we are just adding two matrices where one is just the negative of the other. So we have here 1 plus -1 is 0, -2 plus 3 is 0, -2 plus 2 is 0. But for D, we are adding two matrices that are not of the same size, and therefore the sum is undefined. Now, how do we perform scalar multiplication? If A is a matrix, that's an m by n matrix with entries A sub ij, and C is a scalar, then the scalar multiple of A by C is simply the matrix C times A, that is a product of each entry with C. For example, let us apply scalar multiplication on the following matrices. So for example, we have A, which is a 3 by 3 matrix, as well as with B. How do we find 3A? So to find 3A, we're simply multiplying every entry or every element of matrix A by 3. or that, so that we're simply tripling each element. So we will have 3 times 1 will be 3, and then again 3 times 2, that will be 6, 3 times 4 is 12, negative 3 times 3 is negative 9, 0 times 3 is 0, and you will have negative 1 times 3 is negative 3, 2 times 3 is 6, 1 times 3 is 3, and 2 times 3 is 6. Now for B, we're asked to find the negative of B, so we're simply getting the negative of each entry in matrix B to get the this particular matrix here. Now we're asked to perform 3A minus B. So that is the A, the result of A plus the result of B. We're simply doing it element-wise again. So we have 3 minus 2, that would be 1. 6 minus 0 is 6. 12 minus 0 is 12. And so on and so forth, so that we will have 3A minus B to be equivalent to this matrix. Okay, to be equivalent to this matrix. Now, how do we perform matrix multiplication? If A is an m by n matrix and B is also, so we will have here, how do we perform matrix multiplication? If A is an m by n matrix and B is an n by p matrix, then the product AB is an m by p matrix whose product will have entry C sub ij. So we can easily predict the size of a matrix product. So if we will have here A to be an m by n size matrix, multiply that with B, which is an n by p matrix, with the product will be defined for the two matrices if the number of columns of the first matrix is equivalent to the number of rows of the second matrix, so that the size will be equivalent to an m by p. Okay, so right now what will be C sub ij? C sub ij will be equivalent to the sum of your A sub ik times B sub kj, beginning from k equals 1 up to n. So we will have here A sub I times 1, B1 times j, or B1j plus AI2 B2j plus AI3 B3j plus dot up to AYN BNJ. Now let us demonstrate that one. Find the product AB, where A is we will have here a 3 by 2 matrix multiplied by B, which is a 2 by 2 matrix. Now we want to ask ourselves, is the matrix product AB defined? And we can see that the product is indeed defined, since the number of columns of A is equal to the number of rows of B, so that the size AB would be 3 by 2. So that we will have here C to be a 3 by 2 matrix, and each entry will have the position 11, 12, 21, 22, 31, and 32. Now, how do we solve, or how do we find for C sub 11? So in order to find C sub 11, we are simply going to multiply every entry of row 1 to every entry in column 1 of the next matrix and add them together. So for example, doing that, what do we have? Negative 1 times negative 3, that would be positive 3. 3 plus 3 times negative 4, so that would be 3 minus 12, that would be negative 9. And then to find C sub 12, we are going to multiply every entry of row 1 to the second column of the second matrix. Okay, we're going to multiply every entry of row 1 of the first matrix with the second column of the second matrix. So we will have negative 1 times 2 is negative 2. Negative 2 plus 3, that would be 1. So similarly, in order to find C sub 21, we are now going to multiply every entry in row 2 of matrix A and multiply it to every entry in column 1 of matrix B. So we will have here 4. So we will have here 4 times negative 3 is negative 12. Negative 12 plus 8, that will be negative 4. And then to find C22, multiply second row of matrix A with every entry in second column of matrix B. So we have 4. 4 times 2 is 8. 8 minus 2, that would be 6. To find C31, we are going to multiply the third row elements of matrix A with the first column elements of matrix B. So we will have 5 times negative 3 is negative 15 plus 0. We will have negative 15. And then to find C32, we are going to multiply the third row elements of matrix A with the second column of matrix B. So you have 5 times 2 is 10 plus 0. That would be 10. So that's how we perform matrix multiplication. And then we will have negative 9, 1, negative 4, 6, and negative 15, 10, which is just the same as our answer.